So, Bismillah Rahman Rahim. So, let us start our module 5. The module 5 contents includes the assignment of the sections to structural members, which we have defined in our previous module 4. Then we will be defining the load patterns and then the defining load combinations as per the UBC 97, and then defining the load cases and the concept of the mass source and defining the mass source in the ETAB. For the assignment of these sections to the structure members, there are different several methods. Method one, two, three, and sorry, you can study it out this method by yourself. The first method is the all the members are the same size. Then you have to select the members from the object type. We will go to the select tab and click on the select object type, and then from the object type we will select the beams. It will select all the beams in the building. Structurally, so Bismillah Rahman Rahim. So let us start the module 5. The module 5 consists of the following contents: the assignment of sections to structural members, defining the load patterns, defining the load combinations according to UBC 97. Load cases will be defined, and the concept of the mass source and defining the mass source in the ETAB. The first method is the first part is the assignment of the sections, and it consists of the several methods. Method one, two, three. You can read it out in detail by yourself. But the first method, method one, is when your members are of the same size, then you have to go to the select tab, object type, and select that member, whether you want to select the beam, slab, or the columns. So let me clear this. Go to the select object type, and then you can select columns, beams, bracers, and walls, floors, whatever you want to select. This time you will select beams, and we will assign the beam section which we have defined in our previous module. I will go to assign, click on the frame section properties, and from the section list you have to select your defined sections, which is the B 18 plus 24, and click on apply. You can see within one click you have assigned the beams to all of the structure members. Similarly, for the columns, again click on the columns, select all the columns, and then again this tab is open. Assign the columns, for example 24 plus 24, and click on apply. If I go to, for example, in deviation, you can see that the beams with this section properties of 18 into 24 and the column size 24 plus 24 has been assigned. Similarly, select again the floors, and this time cross this, go to the assign shell slab sections, and assign the slab 6.5 inches. Click on apply. So if I go to the plane view, and you can see that from the slab 6.5 inches thickness properties has been assigned. Now again cross this, select the walls. This time it will select all the walls, including the lift walls and retaining walls. Select all walls, go to the assign shell, this time wall section, and assign, for example, W retaining wall to all of these into the lift wall as well. We will change the properties in the another method. So this is one method. The next method, if all the members are the same size, disappear all the other members and select all the structure members you want to assign the property. Click on this undefined shape and click on this display options and disappear, for example, beams, columns, and floors, and leave the walls only. Click OK. So now you can see all of these are disappeared. Only walls are in here. So if you go to story 1, you can see the retaining wall as well. So I will select the property for the assigned to the retaining wall. I will go to the select properties into the wall section, and I will select retaining wall 12 inches, and you can see it has selected all the walls, but I want to leave only this lift wall, so I can assign the properties to it. So let me clear this, turn on the all story command and select this lift and this one, and right click and click on this show selected object only. Right, so this, you go to 3D, you can select all of these because this is only lift, and click on the lift wall, assign the lift wall, go to the assign shell wall section and click on the lift wall, click on apply. Now the lift wall properties has been assigned to the lifts. So this is method 2. You can apply this method to the beams, columns, slabs, and other structural members. The next method, if you want to assign a specific section to a special member, then select that member and you have to go to the assignment tab, select the section properties. Let me turn on all of these. And right click, show all objects. For example, I want to assign a special section to this beam, for example. Then you have to right click on this beam. So a tab will open and it will show you different information for the beam. It will show you geometry, the assignment, which includes the section properties, modifiers and offsets, and different other sections. It also give you information about the loads, if it is applied or not, and then it will be designed. So it says that the design procedure is complete frame design. So in the assignment tab, this is the section property. If you want to assign a specific beam section, you can select that from the top down menu. Right, for example, let me select this, click on apply. So this property has been assigned. If I display the section properties assigned to the frame, set the view option, click on the object assignment, the frame assignment will show me the section assigned to the section members, and it will show you the different section that has been assigned into the section members. So you can see it has been assigned as a different beam. Let me undo this and let us proceed with the design. So there's this is the 3D view, and now we will assign the let me display only the set building view limits and display only 11 story. We will define the section properties for the overhead water tank walls, and we will define it as a 12 inches, and its FC prime should be 5000 plus. And again we will define the section for the bottom slab of the overhead water tank as 12 inches, and FC prime should be 5000 in overhead water tank slab. Again, you have to apply the different checks as per the CI code if we have done in the previous module. Let me display this portion. This is actually the top of the slab, the top of the horror tank. And if I display the storytelling as well, so it will be actually resting, or the forces will be on the bottom story. So we will select these two and we'll assign the shell slab section flag. The next is, let me display only 11 story and show me only the walls, hide the floors. Now select all of these walls and assign the shell wall sections the horror tank 12 inch, right? So let me show all of the building. So this was the whole story about the assignment. Next is defining the load patterns. So self-weight of the building or the member. For the self-weight of the structure member, select the dead as a load pattern and keep the self-weight multiplier as 1. So please note that if you keep this factor as 0, the software will not calculate the self-weight of the members, right? So then the calculations and the design will be incorrect. So we'll go to the define load patterns. Down the mic one. When you click on the define load pattern, software has already defined dead load pattern and the live load pattern is default, right? So you can see that the dead load pattern, this is the name, this is the type, and this is the self-weight multiplier, right? So you have to keep this as 1. So if it is 0, for example, let me make it 0, modify load pattern, it will become 0. If it is 0, then you have to make it 1 and click on the modify load. The live and dead load, it is actually superimposed dead load. For the live load and superimposed dead load pattern, select the live load pattern and the superimposed dead load pattern. And this time the self-weight multiplier should be 0. Because if you take it as a 1, the software will calculate the weight of the member based on these load members, and it will be overweighted and the structure will be uneconomical. So the live load is also defined. So let me delete this so I can define it again. Write the name is live and select the type as live and click a new load. Select the SDL, which is the superimposed dead load. Select the live, the type is super dead. Select and multiply as 0. Click add new load. So this is the way how you can define the live load and the superimposed dead load.